21st problem in the oscillation. In this problem we will discuss, this is the 21st problem of the chapter oscillation in class 12 HSC board. Here the problem is a 20 centimeter wide thin circular disc of mass 200 gram is suspended to a rigid support from a thin metallic string. By holding the rim of the disc, the string is twisted through a 60-degree and release. Now it performs angular oscillations of period 1 second. Here we have to calculate the maximum restoring torque generated in the string under the undamped condition, and here given that pi cube is nearly equals to 31. Initially we will write what are the given conditions or what are the given in the problem. Initially is given as 20 centimeter wide thin circular disc. Disc is 20 centimeter wide. This means the diameter of a disc is given as a 20 centimeter. Here diameter is given as a 20 centimeter, and initially we will convert all the unit into the SI. Therefore this will be the 20 into 10 to the power minus 2 meter. Diameter is given as a 20 centimeter. Therefore we will convert this diameter into the SI unit. 20 into 10 to the power minus 2 meter. As diameter is given, we will calculate the radius. Radius will be equals to half of the diameter. This will be 10 into 10 to the power minus 2 meter. Also the mass of the disc is also given. Mass is a 200 gram. Therefore we will convert this 200 gram into meter, 200 gram into the kilogram will be this minus 3 kg. This will be equals to 0.2 kg, 0.2 kilogram. Also by holding the rim of the disc, the string is twisted through an angle. Theta is given here. Theta is a 60 degree. Therefore we will convert the 60 degree into the radian, and 60 degree is nothing but the pi by 3 radian. Okay. Now to perform the angular oscillations of the period, T is given equals to 1 second. T is given equals to 1 second. Now we have to calculate the restoring torque. This is a torque. Would be the what? We have to calculate the torque required to generate, or torque generated in the string under the undamped condition. And again the value of pi cube is given as a near about 31. Therefore we know that the equation for tau equals to c theta. C is the restoring torque, where c is the restoring force constant. Now as we have given the time t, we need to calculate the value of c. Therefore we can calculate the value of c by using the equation t equals to 2 pi by under root of I by c. By putting the value of t1 here, this will be equals to 2 pi, because value of t is given as 1, 2 pi under root of I by c. We will take the square on both sides. Therefore this will be equals to 1 square is 1, 4 pi square I into c. Therefore this c will be, value of c will be equals to 4 pi square into I. Therefore the value of c will be 4 pi square into I. Now restoring tau will be equals to c, value of c into theta. Therefore value of c is a 4 pi square into I into theta is the value of theta is given as 60 degrees, so it is a pi by 3. Therefore this tau equals to 4 by 3 pi square into pi into I. This will be equals to 4 by 3 into pi cube into I. Therefore we will solve this equation. 4 by 3 into pi cube value is given as a 31 and value of this I moment of inertia of this will be the 1 by 2 m r square. M and r in this equation, this will be equals to this is a 31 into 1 by 2 mass, value of mass is a 0.2 gram and value of radius is a 0.1 square. This will be equals to 4 by 3 into 31 into 1 by 2. This will be the 2 into 10 to the power minus 1 into 1 into 10 to the power minus 1 bracket square. Therefore this 2 and this will be the 2 or sorry this 2 by 2 is a 1. Therefore this will be the 4 into 31 by 3 into this minus 1 and this minus 2. Therefore this will be the minus 3. Therefore after solving, this is a 4 and 12. 124 by 3 into 10 to the power minus 3. After division we will find out the answer. 3 4 is 12. 3 1 is 3. 3 3 is 9. And so on. This will be the recurring 3 3 3 3. So the answer will be 41.3333 into 10 to the power minus 3. Therefore the answer will be 0.04133 Newton meter square. Therefore the answer will be therefore the answer will be 0.0. Therefore the answer will be 0.04133 Newton meter.